Did you know that the way you connect your electronic components can drastically change their performance?
Have you ever wondered how electricity gets to your lamp and makes it glow so brightly? Or how it powers your video game console, allowing you to dive into exciting virtual worlds? The answer lies in circuits. Circuits are like tiny pathways that electricity follows, guiding it to where it needs to go. They're the invisible force behind our modern world, powering everything from our homes to our smartphones, and even the towering skyscrapers that light up our cities at night. Imagine a circuit as a racetrack, with electricity as the race car zooming around. Just like a race car needs a complete track to race on, electricity needs a complete loop to travel efficiently. This loop is made up of wires and components that work together seamlessly to control and direct the flow of electricity, ensuring everything works as it should. Without these intricate circuits, our world would be a much darker and quieter place, devoid of the conveniences we often take for granted. Circuits come in different forms, but the two most common types are series circuits and parallel circuits. Each has its unique way of managing the flow of electricity. Understanding how these circuits work can help you appreciate the magic of electricity and the technology that surrounds us. It can even inspire you to create your own electronic projects. So buckle up and get ready for an electrifying journey into the world of circuits. Whether you're a curious learner or an aspiring engineer, there's always something new to discover in this amazing field. Let's start with series circuits. These are one of the most fundamental types of electrical circuits. Imagine a single-lane road where cars can only travel in one direction. This is a great analogy for understanding series circuits. That's similar to how electricity flows in a series circuit through one path only. The current has no choice but to follow this single route. In a series circuit, the components are connected one after another, like links in a chain. Each component is a crucial part of the path. The same current flows through each component, and if one component breaks or is disconnected, the entire circuit breaks, and the electricity stops flowing. This is a key characteristic of series circuits. Think of a string of holiday lights. They are a perfect real-world example of a series circuit. If one bulb burns out, the entire string goes dark because the circuit is broken. This can be quite frustrating during the holiday season. That's because the electricity can't find a complete path to flow through anymore. The break in the circuit stops the current entirely. Series circuits are simple to build and understand. They are often used in educational settings to teach the basics of electrical circuits. They're also cost-effective because they use fewer wires and components. This makes them an attractive option for simple projects and experiments. However, their limitations become apparent when one component fails, affecting the entire circuit. This can be a significant drawback in more complex or critical applications. Understanding series circuits is just the beginning. As we delve deeper into the world of electronics, we'll explore other types of circuits like parallel circuits, which offer different advantages and challenges. Mastering the basics of series circuits will provide a strong foundation for tackling more complex electrical systems in the future. Now imagine a multi-lane highway where cars can choose different paths to reach their destination. Each car represents a unit of electricity, and each lane is a different path that the electricity can take. Just like cars can switch lanes to avoid traffic or reach their destination faster, electricity can flow through different paths to ensure it reaches all parts of a circuit efficiently. That's how electricity flows in a parallel circuit with multiple pathways. These pathways allow the current to divide and flow through various branches, ensuring that each component in the circuit receives the necessary power. In a parallel circuit, the components are connected on separate branches, creating multiple paths for the electricity to flow. This setup is crucial for maintaining the functionality of the circuit, as it allows each component to operate independently. Even if one component fails, the electricity can still flow through the other branches, keeping the remaining components powered. This redundancy is what makes parallel circuits so reliable, as a single point of failure does not disrupt the entire system. Think about the lights in your house. Each light fixture is part of a parallel circuit, allowing you to control them individually. You can turn on and off different lights independently because they are wired in parallel. This means that the operation of one light does not affect the others, providing convenience and flexibility in managing your home's lighting. If one light bulb burns out, the other lights in your house will still work because the circuit is not broken. This is a significant advantage of parallel circuits, as it ensures continuous operation of other components even when one fails. Parallel circuits are more complex than series circuits, but they offer greater reliability and flexibility. The complexity arises from the need to manage multiple pathways and ensure that each branch receives the correct amount of current. They are used in most electrical systems because they allow different components to operate independently without affecting each other. This independence is crucial in modern electrical systems where reliability and flexibility are paramount for efficient operation. Now that we understand the basics of series and parallel circuits, let's compare them head-to-head in a circuit showdown. Series circuits: pros, simple design, cost-effective, easy to understand. Cons: if one component fails, the entire circuit fails, limited flexibility. Parallel circuits: pros, more reliable, multiple paths for electricity, individual components can be controlled independently. Cons: more complex design, can be more expensive, requires more wiring. So, which circuit wins the showdown? It depends on the application. Series circuits are suitable for simple applications where a single path for electricity is sufficient. In contrast, parallel circuits are essential for complex systems that require reliability and independent control of components. Section 5: Series circuits in action, real-world examples. Series circuits might seem limited, but they play a crucial role in many everyday applications. Here are a few examples. Flashlights use a simple series circuit. When you turn it on, the battery, switch, and bulb are connected in a single loop, allowing electricity to flow and light up the bulb. Remember those old strings of Christmas lights that would go dark if a single bulb burned out? Those were series circuits. Some water heaters use series circuits for their heating elements. The elements are connected in a line, and the same current flows through each one. Section 6: Parallel circuits in action, powering our lives. Parallel circuits are the backbone of modern electrical systems, powering everything from our homes to our cities. Here are some examples. Your house is wired with parallel circuits, allowing you to operate different appliances and lights independently. The electrical grid that powers our cities uses a complex network of parallel circuits to distribute electricity efficiently and reliably. Modern cars use a combination of series and parallel circuits for their various electrical systems, including lighting, ignition, and entertainment. Section 7: Circuit safety, important things to remember. Electricity is powerful and can be dangerous if not handled properly. Here are some essential safety tips to remember. Never touch exposed wires. Exposed wires can deliver a dangerous electrical shock. Always make sure wires are properly insulated and secured. Don't overload circuits. Plugging too many devices into a single circuit can cause it to overheat and potentially start a fire. Water and electricity don't mix. Water conducts electricity, so keep electrical appliances and devices away from water sources. Unplug devices when not in use. This saves energy and reduces the risk of electrical hazards. Section 8: Building your own circuits. A fun experiment. Building a simple circuit is a fun and educational way to learn about electricity firsthand. You can easily create a basic circuit using a battery, wires, and a light bulb. For a series circuit, connect the positive terminal of the battery to one side of the light bulb, then connect the other side of the light bulb to the negative terminal of the battery. The bulb should light up. For a parallel circuit, you'll need more wires and bulbs. Connect each bulb to the battery independently, creating separate paths for the electricity to flow. You'll notice that each bulb can be turned on and off independently. Remember to handle electricity with care and always supervise children when they are experimenting with circuits. Section 9: Circuits and the future technologies building blocks. Circuits are the fundamental building blocks of modern technology. As technology advances, circuits are becoming smaller, faster, and more powerful, enabling incredible innovations. From smartphones and computers to electric cars and renewable energy systems, circuits are at the heart of it all. Understanding how circuits work is essential for anyone interested in STEM fields and the future of technology. As we continue to push the boundaries of what's possible with technology, circuits will continue to play a vital role in shaping our world. Section 10: Conclusion: The power of understanding circuits. Circuits are everywhere, quietly powering our world and enabling countless technological advancements. By understanding the basic principles of series and parallel circuits, we can appreciate the ingenuity behind the devices we use every day and gain a deeper understanding of the electrical world around us. Whether you're a budding scientist, a curious student, or simply someone who wants to understand how things work, exploring the world of circuits is an electrifying journey full of discovery and wonder. So keep asking questions, keep experimenting, and never stop learning about the power of circuits.